Assalamualaikum warahmatullahi wabarakatuh. Okay, today we have an experiment, the experiment 3, transport across membrane. So what we will do today is so this experiment, so the objective of this experiment is to determine the sucrose concentration which is isotonic to potato cells. So we have potato cells here, and then we have sucrose solution. And then the second objective is to determine the osmotic pressure of potato cells in atmospheric unit. So what we have to do today is actually we will cut the potato using this pot bearer. So and then we will measure the potato strip, and then we put in the solution, sucrose solution, and after few minutes we will measure using the ruler the length of the strips. Okay, so today's experiment is about osmosis. So osmosis, that means movement of water molecule through the membrane of these potato cells, and the movement of water. So that means water molecule will move into and also out from the cells. And then so isotonic solution means that movement of in and out is the same. And then so that means the movement of water molecule in both direction, in and out, is the same. And the second is hypertonic. So hyper means the cell becomes shrink. So that means the movement of water molecule inside the cell will come out more than coming inside. And then for the hypo mean the cell become tergit. Tergit mean macam kembang. So that's mean the cell increase in size. So that means the water coming inside more than the water coming outside. So that's all. That's all for today's experiment. So we will show you how the method of experiment will be done today. Okay, thank you. Okay, next, you have to prepare 20 ml of sucrose solution with different molarities in boiling tubes using the dilution method. The molarities required are 0.1, 0.2, 0.3, 0.4 and 0.5 molar. So you have to record the volume of sucrose solution and the distilled water used in table 3.1. So for the determination of molarities of sucrose solution using dilution method, so for 0.1 molar, so you have to use 2 ml of 1.0 molar sucrose solution and top up the distilled water until 20 ml, and so on. For the next concentration, 0.2 molar, so you have to prepare 4 ml of 1.0 molar sucrose and top up with 60 ml of distilled water. And for the next concentration, 0.3 molar, you use 6 ml of 1.0 molar sucrose and top up with 14 ml. And for the 0.4 molar, 8 ml of sucrose and top up with 12 ml of distilled water. And finally, for 0.5 molar, so you have to add 1.0 molar sucrose, 10 ml, and top up with 10 ml distilled water. So total solution is 20 ml. Next, 15 pieces of potato strip will be prepared using cork borer to have 3 replicates for each concentration. So The length of each strip is 4 cm. So how to do this? Actually, we have to cut 4 cm of the potato strips. Okay, next we have to cut the potato strip. So you can look at this video. So right now, so we have to use a scalpel and then measure the length of the potato strip, and we cut into 4 centimeter of each strips. Step number 3. For every concentration, take 3 potato strips and record their average weight in a table. After recording the average weight of 3 potato strips in a table, then put all potato strips into the boiling tubes containing different sucrose concentrations. Step number 5. After 30 minutes, remove the 3 strips from the boiling tubes, wipe, and immediately record their average weight. Based on your results, draw a graph to show the changes in weight of the potato strips against the molarities of the sucrose solutions. From the graph obtained in step 6, determine the sucrose concentration, which is isotonic to potato cells. Based on the values given in the table 3.2, draw a standard graph of osmotic pressure against the molarity of sucrose solution. From the graph obtained in step 8, determine the osmotic pressure of potato cells in atmospheric unit.